So in this question here, we've got y equals f of x as our starting point, and we want to find f prime of x and g prime of y. So that's in Lagrange notation, and then we need to find d squared x dy squared. So that's the second derivative of x with respect to y, and that's in Leibniz notation. So having a look at it first, we've got a function here of x, which is fine, that's what we've got here. But then we've got another function in terms of y, and obviously these are their derivatives. So what we've got here, first of all, we can start off by making g of y our inverse function of f of x. So g of y equals x. So that'll be our inverse function. And now we've got to do is try and find the derivatives of each of those. So what I would do now is I would represent each one of these in terms of its inverse function and write them as a composite function. So in terms of here, I could write f of x. So f of x becomes, well, what is x? X is g of y. So that become a composite function. So that'd be my f of x. So that can map to that one. And then let's get this g of y in terms of something. So then g of y, what I can do, I know what y is f of x. So that becomes g of f of x. And now what I want to do is try and find what this is. So as it's the derivative, I'm going to take the derivative of maybe both of these. So let's try that. So the derivative of f g of y, so do it in terms of y, of f g of y, so start off with that composite function. That should equal f of the derivative of f of x. So that would become the derivative of y with respect to y. So they should then be equal, because that equals that, and then take the derivatives, again should be the same. And let's run it consecutive with this one. So now, derivative of g of y, well, here we want to go with regards to x. So d dx, so I've got this one here, g of f of x. So now I've got d dx, and I've got g of f of x. So that's a function of x, g of f of x. And that should equal the derivative with regards to x of g of y. Well, g of y is just x. So see if we can find some kind of relationship between these. Well, we can see straight away the right hand side of both equations give me 1. So that's one thing we can run straight away. Now we need to find the derivative of these. Now f of g of y, that's classic chain rule situation. So f of g of y, I'm going to have f prime of g of y. And then by the chain rule, derivative of the inside, I need g prime of y. So that would be that one. And then similar thing here, it's going to be almost the same kind of setup. So I need the g prime of f of x, and then multiply by the derivative of f of x, which is f prime of x. Okay, right, now let's do some simplification. I've got f prime and a g prime, which is what I want here, and I've got a g prime and an f prime, which is I want here. But here I've got an f of x, and here I've got a g of y. Here I've got a y, and here I've got an x, which is exactly what I want. Well, g of y I know is x, and f of x I know is y. So I can change these to f prime g of y, which is x, g prime of y, that equals 1. And I can see here I've got g prime f of x, which is y, and then f prime of x, that also equals 1. So basically the product of the derivatives of two inverse functions will give us 1 on all occasions. So that's our general rule. So that's something there. So that's taken care of that. Now we want to find d squared x dy squared. So the second derivative of x with respect to y. So what I'm going to do now, I'm going to take this bit off the board and then we're going to go and progress with this part. Okay, so we've got our first result. The first derivative, g prime of y and f prime of x multiplied together give us 1. Now we want this one here. So here we want the second derivative of x with regards to y. Now how can we represent that? Well, here we've got our first derivative and that gave us the same result whether with respect to x or with respect to y. So I can use that, take the derivative of that, and then I can represent this. So that's what I'm going to do. So let's take the derivative of that. So here, derivative, so I'm going to need it with respect to y of g prime of y, f prime of x. Now that is my dx dy. So this also equals dx dy. So if I take the derivative of this with respect to y, that will be my second derivative. And I'm going to set it equal to the derivative of this with respect to y. Okay, right. Now, nice straightforward one there. Derivative of a constant is always going to give us 0. So that's set to 0. Now I want the derivative of this. So I've got a function of y and a function of x with regards to y. So I'm going to need some product rule and some chain rule rules here. So first of all, with regards to y, let's bring this up into two parts. So the product rule. So if I differentiate this with respect to y, I'm going to get g double prime y, and then I'm going to have to just multiply with that. So I take the derivative of that and keep that. So I've got g double prime of y, f prime of x. So that's my first result. Now I want the derivative of this and keep that. So now I've got g prime of y and the derivative of that. So derivative of f prime of x dy. Okay. Now as this is a function of x with regards to y, I'm going to need a chain rule. So this will stay. So I'll keep this. So g double prime of y, f prime of x plus g prime of y. That's part of my answer. Now by the chain rule I need to take the derivative of this. So if I have f prime of x, take the derivative, I'll have f double prime of x. And by the chain rule, what is my x? My x is g of y. Now g of y, if I take the derivative of what's inside, I'll have g prime of y. And again, that is still set to 0. Okay, now what have we got here? We've got x, which is dx dy. X is g of y. So what I'm looking for here will be g double prime of y. That's kind of what that is equivalent to. So that's going to be my end goal, to get that out of this. So what I can do is, as it's set to 0, I can bring this all to the other side. So now g double prime of y, f prime of x, that equals negative of this. So I've got negative f double prime of x. And notice here I've got g prime of y twice. So I can just write that as a term squared. G double prime of y squared. So that's that. And now get this on its own, just divide both sides by f prime of x. So now I've got g double prime of y equals the negative f double prime of x g prime of y squared all over f prime of x. Okay, so that's what I've got so far. So I've got g double prime of y here. So that's good. That's what I want to kind of achieve. But I want it in terms of f. So I've got f double prime of x divided by f prime of x. But this g prime of y squared is just spoiling things a little bit. Now, if I could change that in terms of f prime of y, or f prime of x, then things will be good. So if I've got this equation here, let's just write that. Where can we write that? Let's put this down here. Keep it to the side here. So I've got g prime of y f prime of x equals 1. If I want to change my g prime of y in terms of f prime, if I take this function here and divide both sides by g prime, I'll get something in terms of f prime. So then I'll have f prime of x equals 1 over g prime of y. So also in return, I could write that the other way, g prime of y equals 1 over f prime of x. So either way I can write it. So here I've got my g prime of y. So here's a g prime of y. So it's the reciprocal of f prime of x. So if I write the f prime of x in the denominator, that will replace that and also square it because of this term here. So then I've got g prime or double prime of y equals the negative f double prime of x over f prime of x and then f prime of x squared because of this. So f prime of x squared. And then I can just multiply these together. So then that equals minus f double prime of x over f prime of x cubed. Okay, now what can I do now? I want to get this in terms of these different notations. So here I need Leibniz notation. So how can I rewrite this? So g prime of y twice is the same as that. So then let's write our answer up here. So d squared x dy squared. Now I've got the second derivative of x with a negative. Well, what is f of x? That's my y. So then what I could write that is my dy dx. So I've got dy over dx. And note, as it's a second derivative, I can put the second derivative in there, not forgetting my minus sign, and then divide that by the first derivative of x cubed. So then I've got dy dx all cubed. And then that will be my representation of that. And that I will declare that as my answer. Okay, thanks for watching.